Hey everyone, this is your next set of notes for Unit 3. Today we're talking about valence electrons, something called electron dot diagrams or E dot, orbitals, and electron configuration. So a lot of this will be brand new information, so make sure you pay attention. So just a little bit of review. Remember that your electrons in the outer level, those have the highest energy level and they're called valence electrons. So those three outer electrons would be your valence electrons. Just some more review from last class. Remember that if you're adding or removing electrons, that's going to change the charge of an atom, so it's going to give you an ion. For positive ions, those are called cations. That means they lose electrons. Negative ions are anions. That means they gain electrons. The energy level of an element's valence electrons tell us what period on the periodic table that it's found in. So if you're looking at a periodic table and I'm looking at boron's in the second period or the second row, so its valence electrons are going to be found in the second period. Okay, iodine's in the fifth period or the fifth row, so that means its valence electrons would be located in that fifth energy level or that fifth period. Another example would be sodium, Na. Na is in the third row, so that means its valence electrons would be located in the third energy level. Group number in the A groups tell us how many valence electrons are in that atom. So I'm looking at group numbers now. Groups run up and down. If I'm looking at lithium's in the first group, that means it would have one valence electron. Okay? Magnesium's in the second group, so it would have two valence electrons. I skipped the whole transition metal section, and then I'm starting with boron. Boron's in the third group, so 3 valence electrons. Carbon would have 4, nitrogen would have 5, oxygen would have 6, fluorine would have 7, and then neon would have 8. The one exception to this rule is helium. Even though helium is in the 8th group, or the noble gases group, it only has 2 valence electrons. So that would be my exception to the rule. How many valence electrons does fluorine have? So look on your periodic table. Fluorine is in the 7th group, so it has 7 valence electrons. Why is this important? We can use valence electrons to make an electron dot diagram. So we start with writing the atomic symbol, like this, and then we draw the valence electrons around the symbol. Use a dot to represent each valence electron. Start at the top and work your way around the symbol, drawing only one dot at a time until you make it all the way around, and then you can start pairing them up. So I have fluorine. We said it has 7 valence electrons. So when I draw that, I would draw 1 on each side. So I have 4, and then I can start pairing them up. 5, 6, and 7. So that's my electron dot diagram for fluorine. That shows me that I have 7 valence electrons. I will post this video on the class website. Please make sure to watch this and continue to do the other examples on your notes. For now, I'm going to keep on going. Electron configuration is the arrangement of electrons of an atom or a molecule in orbitals. One of the most important relationships in chemistry has to do with electron configuration. This determines how reactive an element is. Electrons are found in orbitals. Okay, so we've talked about electrons being in energy levels. Now we can kind of explain that a little further and put them in sublevels and put them in orbitals. So here's my sublevel names. I have S, P, D, and F. And then it also gives you the shape of those orbitals and how many electrons are in each sublevel. So letter S can only hold 2 electrons. Letter P can hold 6 electrons. Letter D can hold 10. And letter F can hold 14. So right now you don't really need to worry about drawing the pictures. Just know each sublevel and how many electrons they can hold. There's another video, I'll put that on the website as well. So how to write electron configuration. Look at the atomic number of the element. The atomic number tells us protons, but it also tells us electrons. So we can determine how many electrons there are for that element. Step 3, fill in all the sublevels in each column until all electrons are used. So this is going to look a little weird at first, so we're just going to go with it. You have this on your notes, these kind of weird looking letters and numbers. This will be given to you on a test. Basically, it tells you the order that you need to write these in, so I just follow the arrows, and that'll make more sense in a second. Electron configuration is basically just making a map of where the electrons are in an atom. So it's just kind of laying it out for whoever needs to know it. Remember to fill in your sublevels. Sublevel S holds 2, P holds 6, D holds 10, and F holds 14. So let's just do some examples and then it will make a little bit more sense. So I'm gonna go to my notes over here. This is the same notes y'all have. Helium is what we're gonna start with, okay? Helium's atomic number is 2. That's just the 2 on the periodic table. That means it has 2 total electrons. So I'm gonna follow my little arrows. So I'm going to start with 1s, so you just write 1s. And we just said the s sublevel can hold 2 electrons, so we're going to put a little 2 up there. This tells me that I have 2 total electrons. So that's all I have to do for helium. The next one is lithium. Lithium has 3 for its atomic number, which means it has 3 electrons. So if I follow my little arrows again, I'm going to start with 1s. S can hold 2. I need to get to 3, so I have to keep going. So if I follow my next arrow, it says 2s. Again, S can hold 2, but to get to 3, I only need 1 more. So 2 plus 1 gives me 3 electrons. Okay, let's do another one. Beryllium is number 4, so it has 4. We'll start here. So 1s2. We need to keep going to get to 4. So I can say 2s2. 2 plus 2 is 4. So I'm done. My next one is oxygen. Oxygen has an atomic number of 8, so it has 8 electrons. So I can start here, 1s2, 2s2, so that's 4. I gotta keep going. So here's my next arrow, 2p. So remember the p sublevel can hold 6, but I only need 8 total. So to get to this to add up to 8, I can put a 4 here. So 4 plus 2 plus 2 gives me 8. Again, this is like a roadmap to get to your element. It's telling us where those electrons are. Here's chlorine. Atomic number of 17, 17 electrons. 1s2, 2s2, 2p. Remember, p can hold 6. I got to keep going because I'm trying to get to 17, so I'm going to follow that arrow up. 3s. S can hold 2. I'm still not to 17. So I'm going to go to my next line that says 3p. Now, p again can hold 6, but to get to 17, I just need to have a 5. So 2 plus 2 plus 6 plus 2 plus 5 gives me 17. All right, last one. Potassium has atomic number of 19 electrons. So again, follow the arrows, try to do it on your own, and then check it with mine. So here's what it should look like. Again, your exponent should be adding up to 19. So that's your electron configuration or potassium. You also have this box. You don't necessarily have to fill that in if you want to. It's just all the examples that we just did. Okay, we're almost done. Let me scroll through this. Okay, Aufbau's principle, Pauli exclusion principle, and Hund's rule. So the Aufbau principle states that each electron must occupy the lowest energy orbital first. So just like with Bohr models, how we had to fill in the first ring before we could move on to the next ones, it's the same thing for electron configuration. The Pauli exclusion principle says a maximum of 2 electrons may occupy an orbital. Electrons have an opposite spin, so they're moving in different directions. And we can represent them by arrows. So if I have lithium, which its electron configuration is 1s2, 2s1, then my arrows would look like that. And so the little lines, the line that's above 1s and the line that's above 2s, those are basically orbitals. So again, I can have 2 electrons in each orbital. And then my sublevels would be 1s, 2s, and then I have my electrons represented by arrows. And lastly is Hund's rule. This says to place electrons individually in their sublevel before pairing them. So if you were ever having to draw out your electrons, you would have to make sure there's 1 in each sublevel before you start pairing them up, just like with the electron dot diagrams. Okay, that is it. If you guys have any questions, please let me know. Bye, guys.